Once you begin to understand the relationships and patterns associated with angle theorems, along with the specific angle properties for triangles, we can begin to take a closer look at more detailed theorems that apply to polygons. In this video, we are going to specifically focus on right angle triangles, or right triangles, and we're going to look at a theorem that can be used to determine the side lengths on a right triangle. Before we get into formulas and calculations, it's really important that you know how to properly label a right triangle. And you might not think very much of it, but there are some specific terms that are used to describe the sides on a right triangle. So before we talk about those terms, let's just review. We know that this triangle that's pictured here on the screen, we know it's a right angle triangle because of the fact that we have this little square icon in the bottom corner of our triangle. Remember that if you don't see this little square icon, you can't go ahead and assume that your triangle is indeed a right angle triangle. So while the triangle visually might look like it has a 90-degree angle, you always want to be looking for that square icon, which gives you full confirmation that it is indeed a right triangle. So the first term that we're going to take a look at is the term hypotenuse. The hypotenuse is the longest side of a right triangle. Now, in order to identify which side is the hypotenuse, you want to be looking for the side that is opposite from the 90-degree angle. So in the triangle that I have here on the screen, we know that this bottom left-hand corner is our 90-degree angle. And so the side that is directly across or opposite from that 90-degree angle, that side is going to be the hypotenuse. So I'm going to go ahead and highlight it for you in this pink kind of marker. So this side here is the hypotenuse. So although sometimes you might be tempted to look for the longest side on your triangle, sometimes it's not very clear which side is the longest. It may look very similar to one of the other sides on the triangle. So instead, you always want to just look for the side that is opposite or across from the 90-degree angle. The other two sides that we haven't talked about, they are called the legs. So the legs are the sides of your triangle other than the hypotenuse. So that would be this side here that I'm highlighting in green, and this bottom side that I am highlighting in blue. Okay, so we have specific names for specific sides on our right triangle. So once you're able to label the sides of your right triangle, we can go ahead and take a look at how we would actually go about calculating or determining the actual side lengths on our right triangle. And in order to do that, we can use a very specific mathematical theorem, which we call the Pythagorean theorem. The Pythagorean theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The mathematical formula for the Pythagorean theorem is a squared plus b squared equals c squared. Or you might see it written in reverse, and so it might look like c squared equals a squared plus b squared. And so if you're wondering what are a, b, and c, where do those letters come from, we assign the letters a, b, and c to specific sides on your right triangle. And so what that means is we use the letter c to represent the length of the hypotenuse. So when you are looking at a diagram of a right triangle, the side that you identify to be the hypotenuse, you're always going to label it with a lower letter c. The lowercase letters a and b can be used to represent the length of the two legs. So it doesn't matter which side you call a and b in terms of the legs, because remember there are always two sides that we identify as being legs. However, the hypotenuse always has to be labeled as side c. If you mislabel your hypotenuse, so accidentally you use the letter A or you use the letter B, this relationship, this formula will no longer hold true. You need to take the values or the side lengths of the legs, square them, add them together, and that will be equal to the length of your hypotenuse squared. And so knowing this relationship, we can use the Pythagorean theorem to calculate the length of an unknown side of a right triangle. So let's go ahead and actually try a question where we can use the Pythagorean theorem. So here we have a diagram of a right triangle. And again, I know that this is a right triangle because I see the little square icon in the corner. And they've given us two measurements. They tell us that this side here on the far left is 5 centimeters, and the bottom or the base of my triangle is 8 centimeters. What we don't know is the length of this side here. So we can use the Pythagorean theorem to calculate the length of this unknown side. Now, in terms of identifying what side is which or which side is which, remember that the hypotenuse is always the side that is located across from the 90-degree angle. So if my 90-degree angle is down here in this bottom left corner, the side that's directly across or opposite from that 90-degree angle would be the side that we don't actually have a measurement for. So this longest side here is going to be my hypotenuse. And so what I'm going to do is I'm going to label this as side C. Remember that your hypotenuse always should be labeled as side C. In terms of the other two sides, the 5 centimeter side and the 8 centimeter side, it doesn't matter which one you call A or B. It's going to be your personal preference. So I'm going to call side 5, I'm going to label that as A, and the side that is 8 centimeters, I'm going to call this side B. If you want to switch them, if you want to call the 5 centimeter side side B and the 8 centimeter side side A, totally fine, going to work out exactly the same and give you the same answer. So now that we've labeled our sides A, B, C, we can go ahead and use the formula for Pythagorean theorem, and we are going to use algebra to solve for C. So I've written the Pythagorean theorem on the screen, a squared plus b squared equals c squared, and I'm going to go ahead by filling in the measurements that were given to us. So the side that we marked as A, that side is 5 centimeters. So in the place of A, I'm going to put in 5. Now I'm using brackets around the 5 because the 5 also needs to be squared. Then I have a plus sign, and then the value of side B was 8 centimeters. So I'm going to plug in 8. Again, that value needs to be squared. And the entire equation is equal to c squared. So c is our unknown variable, and it's what we want to solve for. So I'm going to go ahead and simplify. So the first thing that I want to do is actually figure out what 5 squared is and what 8 squared is. So 5 squared is 25. 8 squared is 64. And that's still equal to c squared. 25 plus 64 is 89. And so you might be tempted to stop here, but remember that Pythagorean theorem requires you, or at least in this question, you are required to solve for C. But what we see right now in our equation is that 89 is equal to c squared. And we don't want c squared, we want just c. So the plain letter C by itself. So normally when we are solving algebraic equations, we use the concept of opposite operations. So anytime we collect like terms and move terms and numbers on either side of the equation, we always change the sign or the operation to be the opposite. So in order to solve for C, we need to perform the opposite operation of squaring something. So the opposite of squaring a number or squaring a variable would be to square root. So we are going to square root both sides of the equation. Remember that whatever you do to one side of the equation, you should also be applying to the other side. So on the left-hand side of my equation, I now see square root of 89. So if you use a calculator and you take the square root of 89, you are going to get a very long decimal answer. I am going to round off my answer and I'm going to keep 2 decimal places. So I'm going to round my answer to the nearest hundredth, and that means I'm just going to keep 2 values or 2 numbers after the decimal. So the square root of 89 then would be 9.43. And that's simply going to be equal to the letter C, because by square rooting a variable that is already squared, those things are just going to, in essence, cancel each other out. So that is just going to leave you with the letter C. So the answer for the length of side C, our hypotenuse, is 9.43, or more specifically, it is actually 9.43 centimeters. They did give us units, so you want to make sure that you use the same units when reporting your final answer. In example number 2, we are asked to calculate the area of the triangular sail on the toy sailboat. So we can see on our diagram that we have a right angle triangle. We see the little square marked in the corner for us. We have one side as 8 centimeters. The hypotenuse is 11 centimeters. And again, I know that the 11 centimeter side is the hypotenuse because it is the side that is directly across from the 90-degree angle. And then the base, or the bottom side of the right triangle, we don't know what that side length is, and they actually have gone ahead and marked it as side A, so they used a lowercase a there. So if we want to go ahead and label the other sides of the triangle, because we do know that the side marked 11 centimeters is the hypotenuse, we have to use a lowercase c label on this side. And so because the hypotenuse is marked as side C and the base was already marked for us as lowercase a, that means the only letter that we haven't used is the 8 centimeter side, and so we're going to mark that as side B. So the question asks us to calculate the area of the triangular sail. And in case you have forgotten, the formula to find the area of a triangle is capital A for area, which is equal to the base multiplied by the height divided by 2. So do we have enough information to go ahead and find the area of the triangle? Well, we have the height. The height of the sail is 8 centimeters, but what we don't have is the base. We don't know what the bottom side of this triangle is. And so before we can go ahead and find the area, we actually need to solve for this missing side. And in order to solve for the missing side, we are actually going to have to use Pythagorean theorem. So I've put the formula for Pythagorean theorem on the screen, and we're going to go ahead and fill in whatever information we have. So we don't have a value for side A, so we're just going to keep it as a squared in the formula. We do know that side B is 8 centimeters, so I'm going to put in 8 squared, and that is equal to side C, which is 11 centimeters, and that also has to be squared. So this looks a little bit different than example number 1. In example number 1, we were solving or isolating for the letter C. And in this particular example, we need to solve or isolate for the letter A. So we are first going to simplify the equation as much as possible. So I have A squared. 8 squared is 64. And that is equal to 11 squared, which is 121. So because we need to solve for the variable a, the next thing that we want to do is collect like terms. So what that means is I'm going to take this positive 64 and I'm going to bring it over to the right-hand side of my equation. In doing that, it is going to become 121 minus 64. And 121 minus 64 is 57. So we've simplified it down to a squared equals 57. And again, remember that we want to solve for a, not a squared. And so in order to get rid of the squared, we need to perform the opposite operation. And the opposite operation of something squared would be to take the square root. And remember that you need to take the square root on both sides of your equation. So again, if I take the square root of 57, I am going to get a long decimal answer, and I'm going to choose to round my answer to 2 decimal places. And so if I take the square root of 57, that would give me approximately 7.55 centimeters. So the base of the triangle is 7.55 centimeters. And now that we have the measurement for the base of the sail, we can go ahead and calculate the area of the sail on the boat. So again, the formula for area of a triangle is base times height divided by 2. So the base of the triangular sail was the value that we just calculated, the 7.55 centimeters. So I'm going to put that in, 7.55. And the height on the sail was 8 centimeters. So it is this side here. So we're going to fill that portion in. And the whole expression needs to be divided by 2. So 7.55 multiplied by 8 is 60.4. And 60.4 divided by 2 is going to give you an area of 30.2. And remember that area typically uses square units, so it's going to have units of centimeters squared. And so the final answer for the area of the triangular sail would be 30.2 centimeters squared. In our next example, the advertised size of a computer or television screen is actually the length of the diagonal of the screen. A new super huge computer screen measures 30 meters by 25 meters. What should the advertised size of the computer be? So let's begin by actually drawing ourselves a diagram that models the question. So I've drawn in a rectangle to represent our computer screen, and one side of the screen we are told measures as 30 meters, and the other side measures as 25 meters. Now we know that on a rectangle, 2 of the side lengths are going to be the same. So for instance, if this bottom side is 30 meters, that means the top side length will also be 30 meters. And if this right-hand side measures as 25 meters, the left-hand side should also measure as 25 meters. Now, in order to actually get the advertised size of this particular computer screen, companies actually take the diagonal measurement. So a diagonal is the length that runs from corner to corner, or vertex to vertex. So I've drawn in the diagonal for our computer screen in red. So we are asked to figure out what should the advertised size of the computer be. So that means that they actually want us to determine what is the length of this diagonal. So if we actually look at what we've created by drawing in this diagonal line, we've actually split this rectangle into 2 triangles. So you can see here that the diagonal line would be the slanted or hypotenuse side of our right triangle. And the 25 meter side and the 30 meter side would represent the legs of our right triangle. Now, I know that this is a right triangle because I know that in a rectangle, all of the corners or all of the vertices of a rectangle meet at a 90-degree angle. So because I know that, I can go ahead and explicitly draw in the little square in the corner of my right triangle. The next thing that we want to do is label the sides of our triangle with the letters A, B, and C. So the diagonal that is marked in red, so the diagonal, the slanted side running through the rectangle, because I know that that is my hypotenuse, it is the side that is directly across or opposite from the 90-degree angle, that side has to be marked as side C. The other 2 sides, the 30 meter side and the 25 meter side, It doesn't matter which one you call A or B. So I'm going to call the 30-meter side side A, and the 25-meter side I'm going to call side B. So I'm ready to go ahead and set up my Pythagorean theorem equation. So I've gone ahead and written out the formula, and I filled in the measurements that we did know. So side A was 30 meters, so I've plugged that in, and side B was 25 meters, so I've plugged that in. So what we don't know is side C, so we are going to be solving for side C. So 30 squared is 900, and 25 squared is 625. 900 plus 625 is 1,525. And then remember to isolate for C, we are going to have to square root both sides. And if I take the square root of 1,525, I get about 39.05. All right, so therefore we could say that the advertised size of the computer should be roughly 39.05 meters. If you really wanted to, you could even round your answer for this problem to the nearest whole number. And typically screen sizes in stores or retail stores are given as whole numbers. They're not really given as decimal values typically. So we could just round this off and say that it would be 39 meters. In our final example, which is actually example number 4, Zeke drives from his house in Geometropolis to his cottage in Decimal Point. He drives 64 kilometers east and then 135 kilometers north. How much travel distance will be saved when he drives along the new square root expressway? So I've actually gone ahead and drawn two little house structures. So the house that is drawn in black is going to represent Zeke's house, and the little house that's drawn in red is going to represent his cottage. So what we're told in the question is that Zeke starts off from his house and then he drives 64 kilometers east. So if you think of a compass rose, okay, so we've got north, east, south, and west. A direction marked eastwards or to the east is typically moving in a direction towards the right. So from Zeke's house, which I've drawn in black, I'm going to draw a line kind of going towards the right. And the distance or the length of this line would have to be 64 kilometers, since we're told that Zeke drives 64 kilometers east. Then from here, he drives 135 kilometers north. So again, if we go back to our compass, a direction that is in the northwards direction typically represents an upwards direction or an upwards motion. So on my diagram, I'm then going to draw in a line going up. And that's going to take us to Zeke's cottage. Now, obviously, this diagram is not drawn to scale because this distance would have to be 135 kilometers. You can make your diagram much bigger than mine. I'm just roughly drawing it out for you, so you know that this is not drawn to scale, obviously. So to get from his house to his cottage, Zeke has to travel 64 kilometers east and then another additional 135 kilometers north. So together, if we were to add those distances together, that would be 199 kilometers in total that he would have to travel to get from his house to his cottage. However, instead, they are proposing that he's going to save some travel distance and he's going to take a shortcut. Now, the shortcut is a path or a route that takes him directly from his house to the cottage. And so that's the line that I've drawn into the diagram in blue. So rather than taking this kind of side route, he's going to go straight from his house to the cottage, and they call this road the square root expressway. So they want you to figure out how much distance he can be saving if he chooses to travel along this expressway instead of taking his normal path. So this diagram is supposed to model or resemble a right triangle. And so I'm going to put my little square in the corner. And we know that we can solve for a missing side length using the Pythagorean theorem. So let's go ahead and label the sides of our triangle. So we know that the line that represents the square root expressway, this would be the hypotenuse. It is directly across or opposite from the 90-degree angle. So I'm going to go ahead and label this as side C. And then again, the other two sides, the legs, you can choose to call either of them A or B. It does not matter. So I'm going to call the 64-kilometer side B, and the 135-kilometer side I will call side A. All right, so I've written out the Pythagorean theorem formula on the screen, and now we can go ahead and fill in our values. So our A value is 135. That needs to be squared, plus our B value, which is 64. That also needs to be squared, which is all equal to C squared. 135 squared is 18,225, plus 64 squared, which is 4,096, and all equal to C squared. If we add those two numbers together, we are going to get 22,321. And then our final step to solve for C would be to square root both sides. And then if I take the square root of 22,321, I am roughly going to get about 149.4 for my C value. So that's 149.4 kilometers. So I'm just going to squeeze in my units there. So the length of that square root expressway is about 149.4 kilometers. Now, they didn't ask us to solve just for the length of that expressway. They want you to figure out how much travel distance would be saved. So in order to figure out that information, we actually need to find the difference between the length of the original route and the length of the new route. And so to do that, we will have to subtract the two values from each other. So remember, the original route had a path that was 64 kilometers plus a path that was 135 kilometers. So altogether, that was a journey that was 199 kilometers in length. But instead, if we take the shortcut, we are simply just going to subtract 149.4 from 199. And that gives us a value of 49.6. So by taking the square root expressway, Zeke can actually save 49.6 kilometers. So almost 50 kilometers in distance that he could save by taking the square root expressway. So to summarize, the formula for the Pythagorean theorem is a squared plus b squared equals c squared. The Pythagorean theorem can only be applied to right-angled triangles, and part of the key feature or detail to using the Pythagorean theorem is being able to properly label your right-angled triangle. Remember that the hypotenuse is always the side that is directly across from the 90-degree angle. It's also referenced as the longest side of a right-angled triangle. And the other two side lengths are considered to be called legs. When you are labeling the sides in order to figure out which side lengths go in the places or positions of A, B, and C, remember that the hypotenuse always needs to be labeled as side C. The legs can be chosen as you wish. So one side would represent side A and the other side would represent side B. But it is also possible to switch up those letters, and you could instead choose to call this side B and the bottom side could be side A. Doesn't matter, it's going to be your personal preference. Just remember that the hypotenuse must always be referenced as side C.